You're listening to leadai.dev, your daily updates on AI development. Today's topic is agentic AI memory attacks. Cross-session vulnerabilities expose organizations. Here's a quick overview. Security researchers have uncovered critical vulnerabilities in agentic AI systems where memory attacks can persist across sessions and affect multiple users. Now, let's ask our analyst about these developments. What's new? Agentic AI memory attacks spread across sessions?
Security researchers have identified a critical vulnerability class in agentic AI systems where memory attacks can propagate across user sessions and affect multiple users within an organization. Unlike traditional AI security threats that remain isolated to individual interactions, these agentic AI memory attacks exploit the persistent memory capabilities that make AI agents effective at maintaining context and learning from previous interactions. The attacks work by injecting malicious instructions or data into an agent's memory during one session, which then influences the agent's behavior in subsequent sessions with different users. The technical mechanism behind these attacks leverages the way agentic AI systems store and retrieve contextual information. When an AI agent processes user inputs, it typically stores relevant information in various memory components, including short term working memory, long term episodic memory, and semantic knowledge bases. Attackers can craft specific prompts or data inputs that get encoded into these memory systems in ways that persist beyond the initial session. The malicious content then gets retrieved and influences the agent's responses to legitimate users, potentially leading to data exfiltration, misinformation propagation, or unauthorized actions. This represents a significant escalation from previous AI security concerns, which primarily focused on prompt injection attacks that affected only the immediate conversation. Traditional AI systems without persistent memory would reset between sessions, naturally containing any malicious influence. However, agentic AI systems are designed to maintain continuity and learn from interactions, creating new attack surfaces that security teams are largely unprepared to address. The persistence mechanism that makes these systems valuable for productivity and automation also creates pathways for sustained compromise. Memory attacks can persist for days or weeks in agentic AI systems, affecting hundreds of subsequent user interactions. Malicious content gets encoded into multiple memory layers, including episodic, semantic, and procedural memory components. Attack vectors include crafted documents, manipulated training data, and specially designed conversational prompts. Cross user contamination occurs when shared AI agents retrieve poisoned memories during legitimate user sessions. Current detection methods fail to identify these attacks because they appear as normal memory retrieval operations.
Thank you for that analysis. Let's move on. Who benefits from understanding agentic AI memory attack risks?
Enterprise security teams and chief information security officers, CCSOs, represent the primary audience that must understand these vulnerabilities immediately. Organizations deploying agentic AI systems for customer service, internal automation, or decision support face direct exposure to these attack vectors. Security architects working with AI powered applications need to redesign their threat models to account for persistent memory based attacks that can affect multiple users over extended periods. IT directors overseeing AI tool rollouts must implement new monitoring and containment strategies before expanding their agentic AI deployment. AI developers and DevOps teams building or integrating agentic AI systems also require immediate awareness of these security implications. Machine learning engineers designing memory architectures need to implement isolation mechanisms and memory sanitization processes. Platform engineers deploying AI agents in production environments must establish new security controls around memory persistence and cross session data flow. Product managers planning AI powered features should factor these security requirements into development timelines and resource allocation. Organizations still evaluating agentic AI adoption should pause their deployment plans until they can implement appropriate security measures. Small businesses without dedicated security teams should avoid multi user agentic AI systems entirely until vendor solutions include built in protection mechanisms. Companies in highly regulated industries like healthcare, finance, or government should conduct thorough security assessments before proceeding with any agentic AI implementation that involves persistent memory capabilities. Enterprise security teams managing AI deployments across multiple business units and user groups, AI developers building systems with persistent memory, conversation history, or cross-session learning capabilities, compliance officers in regulated industries where data contamination could trigger regulatory violations, IT administrators responsible for multi-tenant AI systems serving different user populations, risk management teams evaluating the security implications of AI agent deployments.
Great insight, really helpful context. How to protect against agentic AI memory attacks. Security implementation.
Begin by conducting a comprehensive audit of all agentic AI systems currently deployed in your organization, focusing on those with persistent memory capabilities or cross session learning features. Document each system's memory architecture, including how data flows between sessions, what information gets stored long term, and which users or groups share access to the same AI agent instances. Establish baseline monitoring to track memory usage patterns, session boundaries, and cross user data access before implementing protective measures. Implement memory isolation controls by configuring separate memory spaces for different user groups or security contexts. Configure AI agents to use session specific memory containers that get sanitized between users while maintaining shared knowledge bases in read only modes. Deploy memory scanning tools that can detect anomalous content in AI agent memory stores, looking for patterns that suggest malicious injection or data poisoning. Set up automated alerts for unusual memory growth, unexpected cross session data retrieval, or suspicious content patterns in agent responses. Establish incident response procedures specifically for memory based attacks by creating playbooks for memory contamination scenarios. Train security teams to recognize signs of memory poisoning, including degraded AI performance, unusual response patterns, or reports of inappropriate agent behavior across multiple users. Implement memory rollback capabilities that allow quick restoration of clean memory states when attacks are detected. Test these procedures regularly with simulated memory attack scenarios to ensure rapid response capabilities. Deploy memory isolation frameworks that create separate memory spaces for different user groups or security contexts. Implement real-time memory scanning tools that detect malicious content patterns in AI agent memory stores. Configure automated memory sanitization processes that clean memory states between user sessions or at regular intervals. Establish memory versioning systems that allow rollback. To clean states when contamination is detected, set up monitoring dashboards that track memory usage patterns and alert on anomalous cross-session data retrieval.
That's a very interesting point. Tell us about competitive context. How memory attack risks change AI security landscape.
Traditional AI security solutions focus primarily on input validation and output filtering, making them inadequate for addressing persistent memory attacks in agentic systems. Existing prompt injection defenses like input sanitization and response filtering operate at the conversation level, but cannot detect or prevent malicious content that gets encoded into memory systems and retrieved in later sessions. Current AI security vendors, including Robust Intelligence, Protect AI, and Lakara, have not yet developed comprehensive solutions for memory based attack vectors, creating a significant gap in enterprise AI security coverage. The emergence of memory attacks creates new competitive advantages for AI security companies that can develop effective countermeasures first. Organizations implementing comprehensive memory security controls will gain significant competitive advantages over those relying on traditional AI security approaches. Companies like Anthropic and OpenAI that build AI systems with built-in memory isolation and sanitization capabilities will likely capture enterprise market share from vendors that treat memory security as an afterthought. This security imperative may accelerate the adoption of zero trust architecture specifically designed for AI systems. However, implementing robust memory security comes with performance and functionality trade-offs that limit the effectiveness of agentic AI systems. Memory isolation and sanitization processes can significantly slow down AI agent response times and reduce the contextual awareness that makes these systems valuable. Organizations must balance security requirements against the productivity benefits that drew them to agentic AI in the first place, potentially limiting deployment scope until more efficient security solutions emerge. Current AI security tools cannot detect memory-based attacks that persist across sessions, and users' memory isolation requirements may reduce the contextual capabilities that make agentic AI systems valuable. First-mover advantage exists for security vendors that develop comprehensive memory attack countermeasures. Enterprise adoption of agentic AI may slow until adequate security solutions becomes available.
Good analysis. Let's continue. What's next? The future of agentic AI memory security in 2025 to 2026.
The AI security industry will likely see rapid development of memory-specific security tools throughout 2025, with major vendors rushing to address this newly identified threat vector. Expect to see memory isolation frameworks, real-time memory scanning solutions, and automated memory sanitization tools emerge from both established security companies and AI-focused startups. Major cloud providers including AWS, Microsoft Azure, And Google Cloud will probably integrate memory security controls into their AI platform offerings, making basic protections available as managed services. Industry standards organizations will develop new guidelines specifically addressing memory security in agentic AI systems. Integration between memory security tools and existing AI development platforms will become a critical requirement for enterprise adoption. AI development frameworks will need to incorporate memory security APIs that allow developers to implement isolation and sanitization controls without rebuilding their entire systems. Monitoring and observability platforms will expand to include memory specific metrics and alerts, giving security teams visibility into memory based attack attempts and system compromises. The long term outlook suggests that memory security will become a fundamental requirement for enterprise AI deployments, similar to how encryption became standard for data storage and transmission. Organizations that invest early in comprehensive memory security architectures will be better positioned to leverage advanced agentic AI capabilities safely, while those that delay may find themselves excluded from the most powerful AI applications due to security concerns. Memory security tools will emerge as a distinct category within AI security platforms by mid 2025. Cloud providers will integrate basic memory protection controls into their managed AI services industry standards for agentic AI memory security will be established by major security organizations. Memory security requirements will become a standard component of enterprise AI procurement processes.
Great analysis. So, what are the key takeaways from all of this?
Implement memory isolation controls immediately for any agentic AI system serving multiple users or storing persistent data across sessions. Conduct security audits of existing AI deployments to identify systems vulnerable to memory based attacks and prioritize protective measures. Establish incident response procedures specifically for memory contamination scenarios, including memory rollback and user notification protocols. Delay deployment of new agentic AI systems until comprehensive memory security controls can be implemented and tested.
And what market signals should our listeners watch for?
Enterprise AI security investment surge. The discovery of agentic AI memory attacks is driving unprecedented investment in AI specific security solutions. Enterprise security budgets are being reallocated to address memory based vulnerabilities that traditional security tools cannot detect or prevent. This shift represents a fundamental change in how organizations approach AI security, moving from reactive input filtering to proactive memory protection. Companies that have already deployed agentic AI systems are facing urgent security upgrade requirements that could cost millions in additional security infrastructure and consulting services. Competitive advantage through security first AI. Organizations implementing comprehensive memory security controls early will gain significant competitive advantages in AI adoption and deployment. While competitors struggle with security concerns that limit their AI capabilities, security prepared organizations can safely leverage advanced agentic AI features for automation and decision support. This security readiness is becoming a differentiator in enterprise AI procurement processes, where buyers increasingly prioritize vendors with proven memory security capabilities. The gap between security prepared and unprepared organizations will likely widen throughout 2025 as agentic AI becomes more prevalent. AI security vendor market disruption. Traditional cybersecurity companies face disruption from AI native security startups that understand memory based attack vectors from the ground up. Established security vendors are scrambling to acquire AI security capabilities or partner with specialized companies to address memory attack risks. This market dynamic is creating acquisition opportunities and partnerships that will reshape the AI security landscape. Companies like CrowdStrike, Palo Alto Networks, and Fortinet must rapidly develop or acquire memory security capabilities to maintain relevance in enterprise AI deployments.
What should developers and operators do with this information?
Audit all agentic AI deployments within 30 days to identify systems with persistent memory capabilities and assess vulnerability exposure levels. Implement memory isolation controls for high risk AI systems serving multiple users before expanding deployment to additional business units. Establish memory security monitoring and alerting systems within 60 days for any AI agents handling sensitive data or serving external customers. Develop memory attack incident response procedures and conduct tabletop exercises within 90 days to ensure rapid response capabilities when attacks occur.
Thank you for listening to LeadAI.dev. Stay tuned for our next daily updates in this rapidly emerging market.